The next logic gate we're going to talk about is the OR gate. So the schematic symbol looks like this. We'll have two or more lines coming in. It looks like a shield kind of on its side. And I could call this A and B, and then the output over here on the right hand side. So the OR gate, it takes two or more inputs, and it outputs a 1 or a logical true if any of the inputs is a 1. Okay, so let me show you the truth table for just this 2-input OR gate. So remember, the truth table has to have all of the inputs and the corresponding output. So the output is going to be A or B. The symbol for ORing is we use this plus. It's a little bit different than bitwise binary adding, and I'll show you some more. So that if our inputs are A and B, so I can write A and B, and I can separate these two inputs. The way we scroll through every possibility of inputs is we just upcount in binary. So if you start at 0, 0, this is the case when we have both zeros coming in on our input lines here. ORing is read A or B, right? So 0 or 0, this is only going to be a 1 if one of these is a 1. So since neither one of them is a 1, the output would be a 0. Now, if we were counting in binary with two digits like this, the next case would be 0, 1, right? After that, the next case would be 1, 0. And after that, the final case would be 1, 1. So by counting in binary like this, we just iterate through every binary number starting at 0, 0 and going to 1, 1. Then we'll make sure that we hit all possible combinations of inputs, okay? And it's important that in your truth table that you have every single combination. So now to fill out our outputs in the table, so this is read 0 or 1. So since this is 1, our output will be 1. This is read 1 or 0. This is true. And 1 or 1, since both of them are 1, that's also a 1. So as you can see, it kind of implements binary addition, right? Because 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. However, 1 plus 1, as you guys remember from the last module, is 1, 0. Okay, so this is where this diverges a little bit from binary arithmetic. But we still use this plus sign. But when we're talking about digital logic gates, we read this as OR. So this is read as A or B. But we can talk more about that when we introduce Boolean algebra. So anyway, I just wanted to introduce for you guys the OR gate, the way the OR gate, the truth table is. This can be 2 or 3 or an n number of inputs over here, but just one output. That's going to be true if one of these, or potentially all of them, is true.